Hello, in previous videos I showed how I made a active loop antenna. Here it is in the garage. Because it's so big to work on, it's very hard to get it in the shed and work on it. In the workshop, I mean, shed, it is a shed. But anyway, yes, I did two previous videos on this, and it's basically a 1 meter roughly diameter aluminium loop, and it has an amplifier in its base. In its base, you can see down there. But and the idea is it will cover roughly 50 kilohertz, because I can hear the time signal on 60 kilohertz. It's up in Cumbria. I can also hear the German one on 77 kilohertz, and long wave comes in well on it. Medium wave's good on it, and it will go up to at least 30 megahertz. But anyway, you can look at the previous videos if you want to see how the original design of it was done. I can try and link them in if I can remember how to do that at the end. But in the last one I was looking at problems in mounting the loop into the box, and this is the old box, and in the sorry, I got terrible guitar, sorry. Anyway, in the previous one, in the previous video, I was trying to find a new way of mounting the actual loop onto the box and keeping the whole thing solid and stable. And that was when I came up with this idea of putting the loop through a piece of aluminium bar and drilling the hole out to fit the diameter of the loop. But I've had nothing but problems with this over the years. The wind is the main problem. It stresses everything. We get some quite high winds here. And anywhere where you've got metal to metal contact is always a source of trouble. No matter how hard you try, water will get in there and cause corrosion. And as you can see, it's actually got in the box, but from all the rust from various screws, you can see the screws on the side there, nuts on the side. That's where it all came through like that. The connection was made by two bolts that went into the inside to the box. But as you can see, water has got in there at some point. But it kept working, even though it had got a bit damp in there. Just as I said, the main problem was the actual contact between the aluminium of the loop and this bar. So I've given up on all that, and I don't know why I didn't do this before. I'm now using these things here, which are basically cable glands for putting cables into waterproof boxes, and they've got rubber seals inside them. If I can take one out, and the rubber seal stayed inside, but never mind. But this seems the way forward. Of course, no matter how hard you tighten these up, they're not going to support that weight of the loop. And that's the amplifier, by the way. Working fine after all these years. It's probably been in use for 7 years roughly. There's no major corrosion on the circuit board, and these transistors have survived quite nicely. They get quite hot, probably 40 to 50 degrees centigrade, but even through the very hot weather it never failed, so everything's fine. It's more the mechanicals that's the trouble with this. The actual electronics is working wonderfully well, and it's very directional, so you can null out noise sources, which is the main reason why I wanted to use a loop here. for long wave to short wave reception. As I was saying there, no matter how hard you tighten this up, it's not going to keep that loop stable. It's going to fall over, and as I found with the other one, you needed a bit of support for that. So this is the support pole, which goes on like that, held on with a capacitor clamp, PVC pipe, and that goes up to here. And then previously I'd had just a slotted, where's it gone? Slotted cutout there. That's the loop would slot into. Then I put tie wraps around it to stop it coming out, and that works very well. It supports it, and it will do again, I'm sure. I've just got to work out now where to position the hole. I'm going to put a hole in it this time. I think it's roughly around there. I'm going to do it where that cross is, and I'm going to try and thread the whole of the loop through that hole and until it gets to its right position. And it may need some tape either side to stop it moving around, but I'm not sure yet. We'll find out later. Or I might put some sealant around it. That might do it, not sure. And it's going to fall over if I do that, but that's not a problem. It's not tightened up. It's not tightened up at the moment. And I think to stop any water coming in here, which is an obvious ingress place, I'm going to probably cover all this with sealant. But I'm not too worried about water, because as I said, the previous one had a lot of water in it. As long as there's somewhere, let me find something. As long as you can find somewhere for the water to come out of. So I've drilled several holes in the box. There's one down there. And as long as you've got somewhere for it to come out of at the bottom, because you don't want the whole thing collecting a load of water in it. So I think what I need to do now is get this loop back in the workshop, if I can get it in there. And I think I've got a flat on there, and drill it and tap it for 3mm, because it will be connecting to a solder tag. And then that will be hopefully a fairly good connection point. And yeah, what else? Used to have a SO239 on the output connector, which goes to the coax. And also you get DC fed up the coax, 12 volts. But SO239's the opposite to a PL259. Certainly not waterproof, and there's a right hassle. I had to cover it all up with self-amalgamating tape. So I'm now using an N-type, and I never had any trouble with N-types outside. They always stay waterproof, but obviously the body has to be waterproofs where the screws are and so on. But I've used hot glue there to try and waterproof it, but I'm not sure if that's the right idea really. Maybe sealant would have been better. I might pull that off and cover it in some sealant instead. And so that's about it. So I think I'll get on there, and as I said, I've got to drill and tap these for 3mm on both ends of the loop. And yeah, so I'll go on and do that. By the way, if you're wondering what the blow lamp was for, this support pole had warped over the years, and it was bent into the shape of a banana basically. So I had to heat it up with the blow lamp, being careful not to melt it, to soften the plastic, and then flatten it on the floor with some bricks on top of it. So it's now fairly straight, which is good. Okay, so both holes are drilled and tapped for 3mm. Might have been a bit close to the edge of the aluminium, but there's no stress on this particular thing, so it's only got thin wires on it, so it's not going to cause any trouble, and that's fine. And just try the other one, I suppose. Yeah, that'll be alright. Yeah, that's no problems. So what have I got to do next? I think I've got to sort that support pole out, drill a hole in it, the same diameter as this, and try and thread it all the way through up to the top. Okay, that's the hole drilled, and that's now the difficult bit's going to be trying to make this go through all the way up. Don't know if I can do this with one hand. Almost impossible. Nope. Okay, that's a bit over with. One-handed. Wish I could do a lot quicker with two. Okay, that's nearly more or less it. Just needs a final tweak to position it. So that's fairly solid. That doesn't need any tape around it to hold it in place. So I'm going to leave that as it is. Be nice to have a top on it to stop water getting down into there. Don't know if I've got anything that would fit over there. I'll have a look. Can't find anything to go on top of this, so I'm going to fill this all up with sealant once it's all finished. But the next job is to pull this out, unscrew this, put this back over here, and attach one of these rubbery seals which won't go in there because of all these fingers, and I haven't got enough fingers on one hand, so I'll do that off camera. So got the rubber grommet in, and I just tighten that up now, and won't tighten it all the way up at the moment. I've got to do the other ends, and then of course get these wires and solder tags screwed onto there. So I'll do that. Okay, next job, getting these solder tags attached, and I'll put a bit of grease on them because two dissimilar metals will cause corrosion, no doubt. Tighten that down, that's fine. And the other one, and that's fine. Put the wire nice and neat-ish. And that wire can go down there, out the way, and that's more or less all I need to do inside the box. So I think I can put the top on and screw it down. Okay, now I've got a horribly messy job filling this up with sealant. I'm using my left hand to do this, which is not as strong as my right hand, but I'm going to have to finish this off with the other hand, and I can put a bit round here as well. Making a right mess of this because I'm right-handed. Oh dear. Cover that bit up with those screws on, and finish it off by using my fingers, which were obviously intended for spreading sealant. Yes, it's a bit messy, looks a bit nasty, but I guess nobody's going to see it where it lives. Well, it does look a bit messy, but it'll do the job. Right, I think the final thing to do is to give it a quick power test in the workshop, make sure it's drawing the right current, then shove it back up the garden and see if it works. Okay, back in the workshop, just about fits in, and I've got it wired up with the cable, which just goes to my power supply. Turn the power supply on. It's already set to 12 volts, which is what the loop expects. Turn it on. 154 milliamps. That's exactly what I expected to see. That's exactly what I had before when I checked it. So it's drawing the right current, but doesn't mean it's working. So now I'm going to take it up the garden and install it and see how it works. So here we are, back up the garden in its final resting place. Okay, it's not completely circular, but it makes no difference whatsoever to its performance. Anyway, I'm going to demonstrate how this rejects noise, but there's not a lot of noise at the moment to reject. But the way I've got this configured is it's connected to my radio in the house, which is a TS2000, and I've got a very low power FM transmitter connected to the radio. I think it's about a milliwatt, so I can listen to it on a portable radio, which is what I've got here. A stick. I don't know if you can hear very well. Now I'll turn the loop. So there was a slight decrease in the noise level, which is what I'm trying to achieve, and most of the noise, I believe, is coming off the three-phase mains cables. I'm just going to tighten these bolts up, wing nuts, but I think most of it's coming off the three-phase which goes across the garden. I'll show you the three-phase. There it is. So I reckon that's what's causing me noise. There are other noise sources around from people's stuff that come and go, but I can't be out here all the time twiddling the loop. Of course, you could have it on a rotator. Anyway, let's go in the radio room. Let's see how it's performing. Okay, here we are with the TS2000, and that's where I was doing that test on top band, 160 meters, and with a wire aerial the noise level would be almost unbearable. As I found over the years, it's gotten increasingly worse. Anyway, let's try a bit of long wave and possibly medium wave. Okay, it's radio 4, which is very strong, station 198, 40 over 9, and if I go back, radio 5, also very strong, 40 over 9. 162 is no longer broadcasting from France, only data now. It's RTE, Ireland, S9. Of course, I might not have the loop in the right orientation for some of these stations. Time signal on 60 kilohertz, so that's quite good really, considering I never expected it to work down to such a low frequency. But there you go. Let's try some of the, won't be anybody on top band, so let's try 80 meters. Nobody on 80 meters. It's the wrong time of day. If I was to do this at night, oh, there's one. So that's fairly good, I think. That's 6. And that's about all I use it for. I don't go any higher than that normally. Occasionally 7 megahertz. Of course, it only works on receive, you can't transmit on it. But there you go. That's the end of refurbishing my aerial. Hopefully it'll last a bit longer than it did last time. Bye for now.